Welcome, on behalf of Olin's Robotics Lab, to the demonstration of HydroFleet, our drone-based autonomous soil sampling system. Due to soil and weather conditions, the moisture content across fields can have huge variance. Farmers, whose time is already spread thin, lack the resources to collect high-precision soil moisture data across their fields. Lack of access to this detailed information can lead to crop over- or underwatering and increased costs to the farmer. The Olin Robotics Lab traveled and talked to local farmers to learn more about the challenges they face with soil moisture sampling.
Soil moisture issues can be a big problem, particularly in dry years that are hot. So a few years ago, we had a beautiful tomato crop. And then it got warm, hot, dry, and we kept watering them, but we did not water them enough. And tomatoes, if you don't water them enough, you can have problems with this thing called blossom end rot. And once that kind of kicks in, you can start losing. We essentially lost the entire crop.
Being able to actually monitor that, and especially like throughout all of our fields, because we have fields here, we have fields down the road at Fork Factory Brook, would be really interesting, and it would help us sort of inform our irrigation schedules and gain insight into how the plants are behaving with various levels of nutrients and water.
Some people have been investigating using satellite systems and doing remote monitoring. The problem with using satellites is they tend to have low spatiotemporal resolution. So the system that we've devised allows you to easily take subfield level samples, and you can build a field scale map.
This information is then served to the farmer in a convenient user interface.
Having a good estimate of where on the field is dry and where it's wet can help us better use our limited irrigation and stop wasting water.
The development process was split into several smaller sub-teams, which focused on soil moisture module design, the drone platform, and multi-drone planning. Our soil sampler uses a custom auger and drilling system to probe 6 inches below the soil. To ensure reliable sampling without needing to land, we developed an active anchoring system using high torque servos. The entire field sampling routine is orchestrated via a custom state machine with dedicated behaviors for navigation, sampling, and landing. Before testing in the field, swarm and flight behavior were tested in a custom simulation environment. To manage the fleet, our multi-agent planner optimizes for full field coverage while minimizing flight time and inter-fleet collisions. Out on the farm, our system showed great progress in its ability to take off and fly with the sampling payload. During flight, the drones were able to use their onboard GPS and inertial measurement units to accurately fly to their target waypoints, including ensuring the payload remained upright during sampling. During drone operation, our system has 2 key safety features. At takeoff, a light and alarm get activated, alerting people to the drone's presence. Secondly is an onboard camera, which is able to identify people and can be used to halt drone operation in their presence. To quantify performance, we collected 4 primary metrics. For navigation accuracy, during field testing, 50% of all flights arrived within 0.43 meters of their target waypoint. For sampler landing accuracy, during field testing, 50% of all landings occurred within 0.23 meters of the target. For measurement accuracy, during in-lab testing, our sampler demonstrated a strong linear relationship with hand probing at an R-squared value of 0.947. And for sampling efficiency, during simulation, we found a significant increase relative to hand sampling in efficiency, which only scaled as farm size increased.
Working with students at Olin through one whole year, going through the difficulty of ideating, designing, iterating, redesigning, testing in the field, through all of that has been incredibly rewarding. It's been challenging, but it's been awesome to see where we are at this point, and to hear some of the feedback that we're getting from our farm partners has been awesome.
Instead of having to go out and test each one by hand if we want to, or just say, we haven't irrigated this one in X amount of time and we think it'd use this amount of irrigation, this would help us to be able to just find out for sure what every field needs and also how the plants are reacting.
A special thanks goes out to Poised and CBM Farms, who lended their expertise for this project. Building the future of agriculture requires bold ideas, cross-discipline cooperation, and strong stakeholder engagement. HydroFleet demonstrates that robotics is a part of this future, improving efficiency and quality of life for farmers.